All right, let's take a look at another problem. This one's number 31. We're taking the limit as h approaches 0 of 1 minus the cosine of 5h divided by the cosine of 7h minus 1. Now again, we're taking a limit at a real number value. We're going to hope for continuity, which means that if we can plug the 0 in using direct substitution, get a real number back, we'll be done with this problem. When you plug the 0 in, you get 0 over 0. Now what that tells us is we have an indeterminate form. We're going to have to do some manipulation to figure out if this limit exists here and if it will be a real number value. Now, there are a couple of different theorems to use. Now, the one that's most frequent doesn't involve the cosine. We've got the limit as x approaches 0 of the sine of x over x equals 1. We also have the limit as x approaches 0 of x over the sine of x equals 1. Now, the top one, the sine x over x, is more common than x over the sine of x, but if you prove one, you've proven the other, so we can use and treat both of them as a fact. So what that means over here is we're going to have to make these cosines into sines because that's how this is going to work out around 0. So we're going to need some trig, which means that we're going to need the conjugate of both the numerator and the denominator. So our numerator was 1 minus the cosine of 5h. So in order to get a conjugate, I'm going to make it 1 plus the cosine of 5h. Now what that will do is make the numerator into 1 minus the cosine squared of 5h, which then we can turn into the sine squared of 5h. In the denominator, we've got the cosine of 7h minus 1, so its conjugate is the cosine of 7h plus 1. Now when these two are multiplied together, they are going to be cosine squared 7h minus 1, which again then means that we get the opposite of sine squared of 7h in this case. Okay, well, we just offset the balance of our equation. We've introduced a conjugate to a numerator, a different conjugate to the denominator. That means in order to make this balanced, I have to put the cosine of 7h plus 1 up top and 1 plus the cosine of 5h in the denominator. Now, in introducing those two parts, and I'll take them down one more step and it'll be easier to see. So I've got 1 minus cosine squared 5h in my numerator. I've got cosine squared 7h minus 1 in the denominator. And then I have the conjugates left. Cosine 7h plus 1 in the numerator. 1 plus cosine 5h in the denominator. Now, the cosine at 0 is 1. So what we've just introduced with these conjugates here is I've got a cosine of 0, which is 1. 1 plus 1 is 2. I've got a 1 plus cosine 5h. That's also going to be 2. Which means that if we evaluated these limits, I'd get a 2 and a 2, or a 2 over 2, which is 1. The limit of 1 is 1. So again, this part here gets absorbed in the problem. So realistically, we're just left with then, I've got now the limit as h goes to 0 of the sine squared of 5h over the opposite sine squared 7h. Okay, well, we do have an opposite sign, a negative sign here in the denominator. I can bring that out to the front of the entire limit. So now I have the opposite of the limit as h goes to 0. I've got the sine squared of 5h in the numerator. I've got the sine squared of 7h in the denominator. Now it is just going to be a matter of matching these signs up to our definition, our theorem, at 0. Sine of x over x is 1. X over sine of x equals 1. Okay, that means then that I am going to, don't forget about this negative sign, so I have the opposite of the limit as h goes to 0. I've got the sine of 5h times the sine of 5h. That's what it means to square them. I've got one multiplied by the other. Then I've got the sine of 7h times the sine of 7h in the denominator. Okay, so I'm close in the sense that I want to be able to have these offset, but first off, I tackled the squaring. Okay, well, what about if I just split them up? And then you can visually see what we are missing. I've got a sine of 5h. I've got a sine of 5h. Those are in the numerator. What do I need in the denominator? Then I've got a sine of 7h in the denominator. And then I've got another sine of 7h in the denominator. So what do I need in the numerator? Okay, so first off, in these denominators, I've got 5h here. I got 5h here. Okay, I need a 7h here. And I need a 7h here. Okay, but again, we've just introduced values, numbers, variables to the problem. So I've got to offset that. So I've got to have a 5h up here. I've got to have a 5h up here. I've got to have a 7h down here. And I've got a 7h down here. Okay, so if you realize we just ended up with the theorems, we've got a 1, a 1, a 1, a 1. I've got h's to cancel, h's to cancel. So what are we left with? We are left with the opposite of the limit as x approaches 0 of 5 times 5, which is 25, divided by 7 times 7, which is 49. The limit of a constant is a constant. Don't forget about that negative sign. So our answer here is negative 25/49. And again, that's the double side limit as h approaches 0 of 1 minus cosine 5h over cosine 7h minus 1. Okay, and how we did that was we converted them to sines. We got to make sure we're following our math when we introduce these conjugates. Okay, and when we introduce the conjugates, we got a 2 over 2, which becomes 1, gets absorbed in the problem. We continue. We see we've got sines to deal with. We want to match them up to the theorem over here, which is x goes to 0, limit as sine of x over x is 1. Limit as x goes 0 of x over sine of x equals 1. Okay, and we got a real number answer, negative 25/49. Okay.